Hello grade 9 students. Welcome to another virtual class. I am Miss Madhu Vadke. We are studying chapter 7 triangles and we are learning how to apply the criteria for congruence of triangles. That is the three criteria SAS, ASA and AAS in solving questions of exercise 7.1. In today's video lesson, we will continue with the same and solve some more questions of exercise 7.1. We have already finished 6 questions of this exercise. So let's start with question number 7. AB is a line segment and P is its midpoint. So we can say that AP is equal to PB. D and E are points on the same side of AB such that angle BAD is equal to angle ABE. So these two angles are equal, and angle EPA is equal to angle DPB, which are marked in the figure. Show that triangle DAP is congruent to triangle EBP, and also AD is equal to BE. Notice that AD and BE are the sides of the two triangles that we have to show congruent. So once we show them congruent, we can say that AD equal to BE, as they are congruent parts of congruent triangles. Since the two triangles that we have to show congruent are overlapping in this figure, let's separate them. So triangle ADP is here and triangle EBP let's mark the angles that are given equal. Angle A of the red triangle is equal to angle B of the blue triangle, and we have AP equal to BP. So we have two parts of these two triangles equal. Now we need to just find one more part in these two triangles equal, and then we can apply a suitable criteria to show these triangles congruent. So first we will list down what is given in the question. AP equal to BP, angle BAD equal to angle ABE, and we are given angle EPA equal to angle DPB. To prove that can be written directly from the question. Now observe the figures. Angle APD is angle APE and angle EPD. Similarly, angle BPE in the main figure is sum of angles BPD and angle DPE. So we see that in these two angles there is an overlapping part, which is angle EPD. Let's mark this angle as X. We start from the information that is given in the question. Angle EPA is equal to angle DPB. So add X to above equation. We get angle EPA plus X equal to angle DPB plus X. And we know that angle EPA and X is angle APD, which is this angle. Also, angle DPB plus X is angle EPB, which is this angle in the blue triangle. So we can say that angle APD is equal to angle EPB. So now we have the third part in these two triangles equal. Let's write down the other two parts. So now in triangle APD and triangle EPB, we have angle APD equal to angle EPB, proved earlier. AP is equal to PB because P is the midpoint, and angle DAP is equal to angle EBP. This is also given. So we have angle A equal to angle B, angle APD equal to angle EPB, and AP equal to BP. So notice that we have two corresponding angles and an included side of these two triangles equal. So we can say that triangle APD is congruent to triangle BPE by angle side angle. Now AD and BE are the corresponding sides of these two triangles, so they will be equal by CPCT, congruent parts of congruent triangles. Question number 8. In right triangle ABC, right angled at C, M is the midpoint of hypotenuse AB. So we can say that PM is equal to MA. Let's write down this much as given. Angle ACB is equal to 90. M is midpoint of AB. C is joined to M and produced to a point D such that DM is equal to MC. So let's mark these segments equal and write down as given. DM equal to MC. Point D is joined to point B. What is to be proved is clearly stated in the question. There are 4 parts to it, so we will deal with each one by one. To prove the first part, consider triangle DMB and triangle AMC. DM is equal to MC and BM is equal to MA is given. So we need to find the third part which is equal in these two triangles. DC and AB are two lines that intersect at M. So we can say that vertically opposite angles are equal. And these angles are included between the corresponding sides that are equal in these two triangles. So which rule is applicable here? Side angle side. Let's write down this much. In triangle DMB and triangle MCA, DM is equal to MC given. BM is equal to AM as M is midpoint of AB. and angle DMB is equal to angle AMC, as they are vertically opposite angles. So this implies triangle DMB is congruent to triangle. To write the correct order, let's find the corresponding vertices. D corresponds to C, M corresponds to M, and A will correspond to B. So the order of the second triangle will be CMA by SAS rule. So if these two triangles are congruent, then their parts are also congruent. Angle BDM will be equal to angle MCA, because they are congruent parts of congruent triangles, and DB is equal to AC. Why did we choose to write down these parts? Because to prove the remaining part of the question, we are going to use them. So let us look at angle BDM equal to angle MCA with a new perspective in the figure. So these angles form alternate interior angles made by lines DB and AC, which are cut by transversal DC. So this implies that DB should be parallel to AC. We will mark these results as 1 and 2. This is the first part. Let's prove the second part now. Angle BDM equal to angle MCA from 1, but they are alternate interior angles made by lines DB and AC cut by transversal DC. So these two angles form alternate interior angles. And since they are equal, we can say that BD is parallel to AC. So we can mark these two lines parallel in the figure. Now if we take BC as the transversal, then angle DBC and angle ACB will sum up to 180 degrees. Why? Because they form co-interior angles. And we know that angle ACB is 90. So if ACB is 90, then angle DBC will also be 90. So this implies angle DBC plus angle ACB will be equal to 180 degrees. Reason: co-interior angles made by DB parallel to AC cut by transversal BC. It is important to mention which transversal is making these co-interior angles, because there are many transversals in this figure to the parallel lines DB and AC. But angle ACB is equal to 90 degrees, that is given. So this implies angle DBC is 180 degrees minus angle ACB, and that is equal to 90. So we have proved the second part of the question. Now moving on to the third part of the question, we have to show triangle DBC is congruent to triangle ACB. Since these triangles are overlapping, let's separate them. So triangle DBC is here. Triangle ACB is here. Now let's mark the corresponding paths in these two triangles that are equal. BC is equal to BC because this is a common side of both the triangles. Then angle ACB is given as 90 in the question, and we have shown that angle DBC is also 90. So these two angles are equal. Also in the first part, we have shown triangle DMB is congruent to triangle CMA. So their corresponding paths are equal. So we can mark DB equal to AC. So now we have two sides and an included angle in one triangle equal to two corresponding sides and an included angle in the other triangle. So we can say that these two triangles are congruent by SAS. So this implies triangle DBC is congruent to triangle ACB by side angle side. So we can say that DC is equal to AB as they are corresponding parts of congruent triangles. But we know that DC is equal to DM plus MC. But DM is equal to MC as M is the midpoint. So this equation we will write as DC equal to MC plus MC. So DC is equal to 2 times MC. I have replaced DM with MC. Now compare the third and the fourth equations. The left hand sides are same, so their right hand sides will also be equal. So 2MC will be equal to AB. This is from 3 and 4. This implies that MC is equal to half AB. And this is what we have to show in the fourth part of the question. So the fourth part starts from this step. What is the reason for this step? DC equal to AB, CP, CT. With this, we come to the end of this video lesson. Your assignment for today consists of these two questions. See you in the next class. Until then, goodbye.